Welcome everyone to a new edition of our CRA Mondays. Good morning, good afternoon, good evening, depending when you are connecting to our session today. We are excited to dive into a crucial topic today that is becoming increasingly relevant in the landscape of secure software development and compliance. And today we have Agustin Benito Betancourt that will drive us through the software hash identifiers and the role in the development of standards. So, Agustin, over to you.
Thank you very much for having me and inviting me to talk about this topic. And so I'm gonna try to describe a little bit what are intrinsic identifiers versus extrinsic ones. That is important to understand the software hash ID. And I'm gonna provide some details about the syntax because that is relevant in order to understand the different use cases. And then I'm gonna invest a little more time in the software hash ID and CRA, that's how I call it, use case versus the rest. And I will finish with 5 takeaways based on my own opinions and experience. As you mentioned, my name is Agustin. I arrived to Software Hash ID through Software Heritage. I'm an ambassador there since 2023. And well, I've been working in the crossroads of open source and business for quite some time. And without further ado, let's go to intrinsic identifiers. So the first thing that we need to that I would like you to understand is that an intrinsic identifier is a marker that derives directly from an inherent natural property of whatever entity. So it's something that the whatever object we want to think about possess. It's not something that we assign. So it's inseparable from the object itself. And I have put here a few of them, and maybe the most relevant one, I will mention this one later, is the first one. Think about an identifier as the Na tag for sodium. So you assign to an element based on the number of protons they have, you assign a tag, you assign a ID. And a different element has a different ID. Different number of protons, which is an intrinsic characteristic of an element, has a different tag, a different pair of words in the periodic table. That's a very, very clear intrinsic identifier. There are others. And I want to compare that with what an extrinsic identifier is, which instead of being a property, a marker of a property of the element itself, is a label that we assign to a specific element. So it's artificial, right? And well, you have several of the popular ones in this context, IP addresses, or the ISBN for any book. Software ID, do not mistake that with software hash ID or purl or CPE or CVE. Those are all extrinsic identifiers. And there is an external entity that somehow manage the relation between the object and the tag and the identifier. So there are plenty of types of intrinsic identifiers based on, for example, if it's physical or the digital nature of the object, or if that characteristic that we are using as a marker for the identifier is persistent or not, if it is content-based, if it is standardized or not. So we can categorize the intrinsic identifiers in many different ways. And we're going to talk about the one very specific intrinsic identifier, which is software hash ID. And software hash ID is a digital, content-based, persistent, standardized intrinsic identifier for any software artifact. And I'm going to go through each one of those keywords because they are absolutely relevant to understand the features that will allow us to get an idea of the impact of using those intrinsic identifiers would have in the context of CRA. So, all right, the first thing that I would like to mention are 5 very high level characteristic of software hash ID. The first one is that software hash ID brings cryptographic integrity. It is decentralized by design. We will see later how important this is. It's comprehensive. Is designed for provenance, and it's very fast to execute. Creating them, parsing them, verifying them, it's very, very fast. All right. I mentioned that that software hash ID is an identifier for software artifacts, and the idea is that it's valid for any software artifact. So here on the left side, you have what software hash ID covers, and it covers from code fragments, from snippets, up to what we currently in our language we call snapshots. So it covers code fragments, it covers files, it covers directories, it covers revisions or commits, it covers any tagging, right? Releases and snapshots. So yeah, it covers a lot. And how it is computed? Well, it follows the design is based on a Merkle DAG, and I'm not going to get into too much detail on what a Merkle DAG is, but it's nothing but a Merkle data tree structure that has several characteristics. A Merkle tree structure is a tree structure where the leaves are in the bottom, and every single node is described through a hash that is the combination of the hashes of the content. So think about the periodic table. When you have a complex compound, the complex compound is in fact described through simpler compounds together, which at the end are nothing but the combinations of the different elements. Right? So it's something similar, but you describe a group of objects through a tree, and each node is a hash that it's a combination of the hashes of the nodes that are below them. And at the lower level, you have the leaves, and that's the content itself. Now, it's direct because the route between one node and the other one goes in a single direction. It's acyclic because you cannot have round path. So you see the graph describes pretty well what we are talking about. So you have the content, the code down on the bottom, and then you have the directories, and the hash of the directory is nothing but a combination of the content that that directory incorporates. And the same with the revisions, the same with the releases, the same concept with the snapshots. So that's why we call it comprehensive. About the syntax, very short description hopefully. So the software hash ID has 2 parts. The first part is the core identifier, and the second part are the qualifiers. Now, the core identifier is mandatory, and that's the identity of the software artifact. So it's the hash of the sleeves of that tree. And then you have some optional qualifiers. And the optional qualifiers provide context in 2 different ways. The first one is the where. It solves where is that piece of software. And the other one points to the exact subpart of the software. So when you combine the three, you get a full software hash ID. Let's get into the core identifier, the mandatory part. There are 4 different elements in that core identifier. The first one is the prefix. In this case, SWH. That doesn't change. Then the scheme version. Think about it as major release. We are in version 1, so you will see a 1. Then is what we call the object type. And we mentioned before that software hash ID as an intrinsic identifier, it covers from snapshots down to snippets content. So we have one object identifier for what we call the content, the source code or the files or the blobs, one for the directories, one for revisions or commits, one for the releases or any tagging, and one for the snapshots. And then you will see in the software hash ID dir if it corresponds to a directory, for instance, right? And then the hash itself. The object ID is the hash itself. I will put an example later. If we think about the qualifiers follow some simple rules. Each qualifier is specified as a key value pair, and you see an equal separating them. Then you have different qualifiers as separated among them with a semicolon. And then there are some qualifiers that are only valid for specific object types, and then there are qualifiers that only matters when they are only valid when they are in the presence of another qualifier. So there are some dependencies among the qualifiers, let's say. And here is the description of the qualifiers. We have the fragment qualifiers, which describes subparts of the content, and then the context qualifier, which sort out the question of where. I'm not going to go into details, but you can see there that you can point to lines, so snippets, or bytes for binaries. And then when we talked about context, you can point to the origin. So that's let's say the original source, but you can point to a different URL because the software is located there. And then imagine that within a repository, you might be talking about a revision and you want to know where it's in that repo, then you would go to path and anchor. Okay, so it brings a lot of possibilities when it comes to answering the question, where is that piece of software which has this identifier, this core identifier. And here is an example that condenses all that information. We have the core identifier in the upper part. You see the SWH, which is a prefix. Then we have the scheme version, number 1. And then the content, there are 5 possibilities. You have the 5 possibilities there, the 5 options there. And then the object ID, the hexadecimal string. And then the qualifiers, you have an example of qualifiers on the right side. This is a well-known example of the Apollo 11 code that is hosted at the Software Heritage Archive. So you see where is the origin. The code currently is on GitHub. But you can find it, you can find it in the Software Heritage Archive. Instead of expressing that into a URL, we are expressing it here with a ID, with the identifier, but you can express it as a URL also. Then you have the anchor and the path to know exactly where is that snippet. Those lines correspond to a specific file that is in a specific place, which you describe as an anchor or a path. Okay, there is a canonical order for the qualifiers. but it's just good practice. It's not mandatory. Okay, so this design for this intrinsic identifier, software hash ID, and this syntax guarantees that the software hash ID is unequivocal, which means that basically two different artifacts are identical if they have the same core identifier. And two different core identifiers correspond to two different software artifacts. Simple as that. And then in addition to that, if we bring the qualifiers, two software hash IDs represent the same artifact, despite being in yeah, let me be strict with this. They represent the same software artifact if both the core identifier and the qualifiers are identical. No matter of the order of the qualifiers. Again, the order is not mandatory. So that's what we refer to when we say that software hash ID is unequivocal. And why is this relevant? Well, all this syntax and this description has been standardized, and that, as you know, it brings a lot of value. So it's an ISO standard, but it's not any standard, it's an open standard. Published under a community spec license, community specification license. And as we expect, is run under an open governance model. So you can contribute, you can contact, you can participate. I put in the slide deck a few links. And like any open standard, you need to have, together with the specifications, open source implementations, open reference implementations, and you can see there one, but if you click on the links, you will see different ones created by different people or organizations with their language of choice. The reference one is in Rust. I am not going to show because we only have half hour, so I'm not going to show the reference implementation and how does it work, but I leave here in the slide some links on how to install it, and the guide to the command line tool. It's a command line tool. You can compute, create software hash IDs, you can parse them, and you can verify them. And it supports not just the core identifiers, but also the qualifiers. And here you have, it's very simple tool. The accuracy is the main goal here, and to show developers how they can create their own tools. All right. And I added here different links. If you visit swhid.org, that's a website. You will find there the specification, the implementations, and then there are some publications there related with software hash ID, and then some use cases also. All right. And well, there is. I recommend you to join the mailing list. The link is there. And let's describe very quickly some use cases. But before that, I would like to open the mic for questions. If you have any question, please shoot. If not, I will go to the...
Yeah, we have one question in the chat by Ria. Ria, do you want me to read it or you want to raise it?
Okay, will the slides be shared? Yes, of course.
The other question, and you may be getting this because I see you have a SWHID and purl, but I was curious whether these were intended to be interchangeable or were they actually different ID models?
They are different. They are different, and they meet different purposes. And I will talk specifically about this. Just for now, when I describe it, what an extrinsic identifier is, I put purl as an example, while software hash ID is an intrinsic one. So derived from that, they are they are different, and they meet different purposes. Although and this is a spoiler, as I will show with software hash ID, you can build, let's say, the same thing that you do with purl. So I'll show you. All right, let's talk very briefly about the number one. The first use case is software heritage. Now, software heritage was inventor of software heritage identifier, which is a precursor of software hash ID. Is still today the largest implementation of software hash ID. And it's also software heritage is today still the main driving force behind the software hash ID working group that leads the open standard. But yeah, hopefully, as more people implement software hash ID, in fact, already that is the weight of software hash of software heritage is reducing over time. So, as you know, software heritage basically is the universal archive. Basically, it's a global long-term effort to build a universal archive for all the software, the source code, and this effort is resilient and sustainable. It's designed for long term. And the only thing I will mention about the mission is that it goes beyond the software. At the end of the day, if we agree that software is knowledge, what we are doing at Software Heritage is basically preserving the knowledge in source code language, right, or in source code form, in digital form. And that was recognized by UNESCO. So Software Heritage became an UNESCO project. Is the entity that is driving the preservation of the source code, the knowledge heritage. All right, but in summary, software heritage is basically three things. The universal archive, which I'm not going to talk about much here. I'm going to talk about the reference catalog, because at the end of the day, you can archive whatever you want. You can build a facility in the North Pole and put all the software there, all the hard drives there. But the idea is that you not just archive it, but you use it. And in order to use it, like any library, you need a catalog. And that's what Software Heritage did. It created a catalog. It was not done. It needed to be done. Just like the technology for archiving, the software needed to be created for this scale. The catalog needed to be created for this. And software hash ID is a fundamental piece of that catalog. And then I will mention very briefly a couple of projects, because just like the Alexandria library it was a place where all the knowledge, the people that wanted to study the papers and the books, well, there were no books, right? There were pergamins, used to go to. So it's a research infrastructure, but not just to consult it, but also as a target, because you're hosting all the software. So the archive is huge, and as I said, software hash ID is a fundamental piece of the catalog that allows that somehow manage the software. So it means that it's already tested. It is proof in a very, very big environment. As you can see there, we are talking about 3 petabytes. It's a lot. Yeah, it's huge and does nothing but grow. And it's a resilient infrastructure, right? And there are mirrors in different countries. So the central node is in Paris, and there are two more nodes operational. One is going to be operational this year, and then we are expecting another one soon in Spain. All right, I added there some links if you do not know anything about the archive. Okay, this is the important part, the catalog. And the catalog was built for the purpose, and software hash ID is a fundamental part of it. So the data model that follows that has been designed is uniform across the entire archive. So you don't, in summary, you don't manage software. You manage the IDEs, the software hash IDs. And then when you know what you're looking for, then the system goes and pick up the software. But the consulting, the identification, all those operations are done on memory with the hashes. Mm-hmm. It would be impossible to manage, to provide a usable service so you can actually consult the software if you manipulate directly the software. And another interesting point is that if you have to, if you work directly with the software, then you would end up with the same software over and over and over again. In order to achieve deduplication, you need a very, very accurate identifiers on it, and with also very low granularity, right? So deduplication means that you are not storing the same software twice. All right. So de facto, what the archive is, it's a graph of the software development evolution. So it's basically how our knowledge as society is evolving throughout time, which makes it a very interesting research infrastructure. And in order, if you are interested and there's, in the context of the CRA, of legislation, I put here some projects that you might be interested on. Code Commons is about metadata, incorporating metadata, standardized metadata into software. It's a big project with many organizations participating, and Software Heritage is one of them. Then you have there Software Heritage Sec, which is about collecting CVEs and trying to build a graph with vulnerabilities. So vulnerability A affects this piece of software, but which other pieces of software are affected? Think about, again, the Merkle tree. And then those of you who are into AI probably are familiar with the StackV2. Is the main open data set for training AI models. It was created in collaboration with Software Heritage. And without software hash ID, it would have been impossible to do that. So yeah, that's what I wanted to reflect here. If you want transparency into AI, the identifiers are essential. Otherwise, you cannot manage the amount of software that you're dealing with. All right. Let's go with another use case. This is a very interesting one. You probably learned about this a few years ago at FOSDEM. So back in 2018, 2019, Intel created a POC. Probably you know Alexios Savras. He was leading that. And the idea was, how can we fulfill the open source license obligations as a company? And they were focusing on 4 obvious cases. The first one is, what about unmodified open source software? So they have to provide the source code, the open source code to their customers across their supply chains. So they were trying to figure out how to do that. And they also, modified open source software. So they have to also provide that. They have to provide their own open source software. And then the modified open source software that includes their own software, right? So they were looking, they separated and structured those 4 use cases, and then they tried to find ways to achieve that. And they ended up realizing that combining software hash ID with the availability of the archive, they could achieve those 4 use cases. And again, think about the duplication. That's an important element here. And in order to be able to fulfill those with all the requirements that a corporation have, what they did is becoming members. So they became members of Software Heritage, and they fulfill the obligations. So they are using software hash ID internally. Okay. Now, I mentioned that software hash ID has some qualifiers, and those qualifiers can solve the question of where. So if you combine the object identifier and the right qualifiers, you can build a purl. So you can bring into the table all the advantages that an intrinsic identifier has with the advantages that purl has. So to answer the question, what is the relation? You can make them complementary if you want to, but you can just simply use software hash ID if you want to. And I put there the example. So imagine we are talking about a specific kernel release, and then you have there how the software hash ID, the core identifier, in the first bullet point. Then the strict equivalent to purl would be the second bullet point, where you point to the origin. And here's another where things start to get really interesting. You can add to the origin the visit qualifier, so you can point to a different place where you can find it. In this case, it's pointing to the archive. So if the curl project decide to change the URL, or it disappears, hopefully not, we would be in very big trouble, you still can find it in the archive. Or you still can find it in your own software hosting platform, if you have it there. So the core identifier does not change, because you're talking about the same piece of software. You just simply change you can change the qualifier. So your auditors can still refer to the same ID. Okay, let's move on. I'm gonna talk very little about this because I haven't prepared this part too much, because I have a talk on Wednesday about this specific point. But I will say a few things about SBOMs and software hash ID very quickly. One of the things that happens when you start using software hash IDs is that you realize that when you're dealing with declarative machine readable SBOMs, that you can simplify a lot of information that is there just by simply using software hash IDs. A side effect is that you resolve the naming ambiguity that software packages bring. If you are into distros, I come from the distro world, that's a nightmare, right? And using intrinsic identifiers like software hash ID really solve that problem. You can customize granularity. It's not a package level anymore. If there is a snippet that is relevant for whatever reason, you can actually point to it. You can identify it in your SBOM. You maximize accuracy. That's for sure. That comes hand in hand with the granularity point. And then one thing that you get is that you become standardized format agnostic. So it can work with both SPDX or CycloneDX. A lot of people ask me, well, what about the checksums from Git? Well, software hash ID is platform independent. And that is relevant because when you are in open source, you are dealing with several platforms, and it might be different from the one you're using internally in your corporation. And then they work. It doesn't matter internally or public. They work the same. You can use software hash IDs in both contexts because it works the same for proprietary and for open source software. It doesn't matter the license. And the combination of the hash plus the qualifiers, so the specific part of that software and the where, that combination brings traceability into a different level. So in summary, enables SBOM scalability, which to me, with the current approach we are having of declarative machine readable SBOMs, is a significant challenge. And I'm just going to put a few examples. Without doing much, everything that is put there in red, you can actually substitute that for a software hash ID. In this case, I created an XPDX SBOM for Ocular, and just software hash ID, and you can remove a lot of all that information. But when it comes to licenses, you can actually point to which file, which snippet has that particular license. So, you can go, the granularity and the accuracy is significantly higher if you want to. And the same applies to CycloneDX, exactly the same. But even more, and this is also relevant in this context, what about the vulnerabilities? How do you express the versions that are affected? Right? For example, you just provide the software hash ID for the specific revision, period. And where did you get it and what is the origin? All right, so there are a couple of presentations about this particular topic in the open chain context. So you have the links there that are happening that I'm doing in March. And finally, we get to the core point. Any questions so far?
I would have a question. You mentioned you can easily reference like affected versions or vulnerabilities, but this would imply that you know all the exact versions that are vulnerable. So it's not possible to state like, I don't know, anything before version X is vulnerable.
Oh, yeah, of course. But you can say you can point to a specific version that is affected, and then, for example, provide another software hash ID for the maximum and the minimum, or the starting point of the sequence and the end point of the sequence, and you can express that with two software hash IDs.
But only if I have access to the source code repository.
Yeah, of course. I mean, if you know where that software is, if it's public, you can either point directly to the origins, or you can look for them and point to the software heritage archive, or to both. You can include both qualifiers. Yes, in this case, obviously, the software has to be public. Yes, of course. Otherwise, you can do the same.
Proprietary software, for proprietary software Hash ID doesn't work at all, right?
No, it does. It's the same. I will mention that specifically now. Yes. We are not talking. I haven't specifically named open source software. So the open source software is linked to software heritage, right? Because it's the archive of the open source software. But software hash ID is license agnostic. It doesn't matter. I'll talk about that now.
Okay, thank you.
All right. Who operates the Merkle tree and why should I trust it? So the Merkle tree refers to two things. It's how it is designed, how you construct the software hash ID. It's designed as a Merkle tree, and who is in charge of the design? That's the software hash ID working group, which is behind the standard, the ISO standard. Just like any other open standard, it has a specific working group with a specific public governance document, and those are who manage it. I'll try to show the URL, the website where you can find the governance document. There's only a single tree. Correct. Again, it's intrinsic, so there is no entity managing the labels. Each hash is content-based, so it's created through the content. Now think about a checksum. A checksum is the content of a specific commit, but it also includes a timestamp, includes the author, includes a few things. So that's why it's not content-based, because the same software committed in two different times will have two different checksums. That's why it's not valid or as a content identifier, because it brings more stuff. No, so you can download the software from multiple sources. Okay. The core identifier, if it is the same bit-by-bit software, the core identifier will be exactly the same. Now, if you want to identify not just the software, but where it comes from, and a specific batch of lines of that software, then the qualifiers of the software hash ID also have to be the same. So this goes down, this question, I try it, obviously not with a lot of success. Sorry about that. Let me go back. I tried to answer that here. All right, we are here. The concept of that is univocal. If you think about the core identifier, it says nothing about the sources. If they are bit by bit identical, you take two different pieces of software, you build the software hash ID. If they are bit by bit identical, you know that is the same software. Now, what it's not saying is that it comes from the same place. If you want to make sure that it comes from the same place, then you bring the qualifiers in. And now, if the core identifier and the qualifiers are the same, then you know that you are referencing the same software, which means that it's the same software, the same piece of software from the same place. If it is compiled different, then the binaries are different. So if you are identifying the binaries, obviously the binaries are different. So they will have a different software hash ID. Now, if the source code is the same, then they will have the same software hash ID for the source code. If it is bit by bit identical before you compile it, you will have the same software hash ID for the sources, but then you will end up with a different binary. So you will end up with a different software hash ID for the binary. It's the same. So the qualifiers. Let me go for the qualifiers. The qualifiers, you can name lines if you're talking about text, or you can go for bytes if you're dealing with binaries. Okay? So it works for binaries, it works for source code. How do you generate it? There are different reference implementations of the standard. So there are different tools. And here in the slide deck, you will find, well, if you go to SWHID, softwarehashid.org, you will find there a tab that says implementations. But I have here in this slide, I have links to that section and links to the one specific implementation, one specific tool, open source tool, to create, parse, and verify IDs, software hash IDs. Oh, sorry. So I have answered in the last few minutes, I have answered the questions related with how do I create the software hash IDs, and a couple of questions that are related with the modifiers, sorry, the qualifiers. What happens if I download the same software from different sources? Will they have the same software hash ID or not? And if the same software version is compiled for two different architectures, will the result have the same software hash ID or not? Those are the questions that I hope I answer. Okay, sorry about that. All right, let me go back to where we were. So after dealing with a few use cases, let's go with the... Okay, so there are 5 elements that when I was dealing with the different use cases, I was close to the work this working group was doing in 2024. I detached throughout 2025, and I'm coming back. So, by the way, there is a lot of great content that you guys have done. Congratulations for that. It's very, very useful. And so I was trying to distill what are the characteristics that are more essential, for the context of CRA. And, there are lawyers, there are implementers, there are auditors, compliance experts. So instead of going profile by profile, I thought, okay, let me just distill what are the core functionalities or characteristics of software hash ID that are relevant. So I don't go one by one through all the use cases because there are tons of them. So let's start by these 5. Now, intrinsic ID for any software artifact. And by any software artifact, I'm not talking just about source code or binaries. I'm also saying that it's content-based. So the license doesn't matter. Right? This is a content-based software identifier. The license doesn't matter. It is persistent. This is relevant in this context because it means that it do not degrade. It does not change. If the software do not change, the ID don't change, and the other way around. If the software change, the ID changes. Okay, the structure, the design is relevant for many, let's say, features, right? So I'll go through that later. And then also, it's important that it's an ISO standard. Now, let's go to what I think is the core of the talk. The fact that it's unequivocal and verifiable locally or through a service, it doesn't matter. You can verify it. It means that you can. I put resolved, but it's no naming ambiguity anymore. And this is a problem that we face in software very often. Is license independent? So yeah, software hash ID works for proprietary software. So if you are in a corporate environment behind the firewall, you will have your software hash IDs for your open source software, and you will have your software hash IDs built in the same way with the same tool for your proprietary software. And you can provide your SBOM with your software hash IDs to your downstream, right? And then if you want to, you can point to the origin of your open source software, which will be transparent. You can point to software heritage archive if you want to have, let's say, like a backup, and you point to where are you hosting your software, your proprietary software, if you want to. And if you don't want to, you can provide a service to your downstream where they can consult based on this software hash ID. They can consult which piece of software they are talking about. So you can create, let's say, your own archive of your own proprietary software and provide your own service for consulting just for your downstream or your legal departments or your external auditors, suppliers, or authorities. Okay. I think I'm completely overdone with the time, or what? Is that correct? How am I doing? I lost track.
We have 5 more minutes.
Oh, sorry about that. I wanted to leave time for. Okay. Is technology independent? This is very important. So hopefully we will see lots of, like we have already, but we will see more proprietary and open source tools using and generating and manipulating software hash IDs. Is platform independent? I mentioned that. Is single bit tamper detection? If it changes 1 bit, different software hash ID. And those of you related with security will understand the implications of this. And it's trusted in the sense that it's an open standard with open governance, so you can participate. If software hash ID becomes relevant to your company, then you can participate in the standards. If there's something, a use case that is not covered, you have a place to go and participate and bring it. Okay. Now, if you combine software hash ID with the archive, then you get extra features. For open source, now we are dealing only with open source software, right? Public software. Now you get provenance in a way that it's a very important feature in the context of CRA. So it's something that we as open source people can provide that and guarantee in a transparent way. And then also traceability, because it's a graph that because of the Merkle tree structure, you can check the evolution of the software, the changes, and how the software have evolved. So it brings traceability into the equation. You don't have to do it yourself now. It comes somehow as a feature by using the archive. And then persistent resolvability. Right? That's another of those features that are very, very relevant, especially when you think about the 10-year period mandate. You can point to the origin, but now you are safe saying, okay, if something happens, my ID is still valid. I'm pointing to the software heritage archive. And then if you use the archive, you can find software through the name or the URL, but you can also find software through the core identifier or the full software hash ID. So you actually put that into the archive, no matter if it's through the API or the website, and it will give you the software and you can download it. All right. So very quickly, 5 takeaways. To me, intrinsic identifiers adoption, it's going to be unavoidable. The software, now that machines create better and better software, the amount of software is exploding. I don't see any other way of managing such an amount of software that using software hash ID, and not just for humans, also for the machines themselves. Software hash ID is universal in many ways. I mentioned the proprietary versus open source. I mentioned source code versus binaries, but in other ways also. It's standardized and it's tested. Software Heritage use it, and they manage an insane amount of software. It's a very complex and demanding environment. This idea of locking, it's very relevant to us. So we want to identify software in a way that we are not attached to a platform, or we are not attached to a tool or a language, or now we want to, or a geo or whatever, right? And then the single point of failure, this is relevant. When you use external identifiers, this is a concern. Who's managing the translation between the labels and the object, the software in this case itself? All right. The combination with the archive, it brings value not just for open source people, but also for academia, but public administrations and industry too. I describe a little bit the Intel case. And in my view, when we think about complex supply chains, in the CRI context, it's going to take a while for us to be able to manage those environments, right? In the CRA context, in my view, using software hash IDs take us a little bit closer to that goal. And that's about it. Is there any other question?
I think we have, I know that we are out of time. The first thing, Agustin, thanks a lot for your presentation. I think that the number of questions and comments in the chat really make clear the value of today's session. I don't know if we have time for maybe one more question. I know we are over time, but
Ole has a question there that, a concern that he still don't see the where does the Merkle tree fit in. If you think about the syntax, the syntax, okay, you will find. Let's put it this way: you will find a link that describes the data model of software hash ID within the software heritage context. And then if you read the syntax, what you see is that the syntax describes a Merkle tree. So how you construct, so it's not explicit, but it's implicit. So you don't go to the standard and say, this is a Merkle tree of this kind. You just describe the syntax but in the data model it's described. Let me see if I can find right away the link, because I have it here in the slide deck. Here. Let me stop sharing. And let me see if I can find. Let me just share. Sorry, let me put a link in the chat. I think it's going to be easier. Chat. All right. Sorry. Ola, you will have I think you will find all you need there. And if you, together with the syntax, which I will also put there, you will see the relation between the two.
Okay, I will try to extract the chat because we were quite active today there, and share it along with the recording. And Agustin, if you can share with us the slides, we will put all things together so everyone can check it.
You'll have them on Wednesday. So I also add the content for the SBOM talk. So I put a little bit more content on the SBOM side. Yeah. And then
no problem at all, Agustin. I mean, yeah, by the end of the week is perfect. We usually upload the video the week after. So yeah, I want to say once again, thank you for the presentation, and yeah, we'll keep in touch. And thank you everyone who attended the session today. We were a bit longer, but I think it was well invested time. So thank you very much, all of you, and see you in the next CRA Monday.
Bye-bye. Thank you.